Hey everybody, welcome to Bill Sky, the C++ guy, and this video is a continuation of the previous video, which was an overview of operator overloading of the increment and decrement operators in C++. Now those operators are also available in C, but it's not so easy, if even possible, to overload them, but in C++ it is. We also talked about the difference between prefix and postfix operators. So go ahead, if you haven't watched that, I really recommend that you watch it, because kind of some of the stuff we do in this video is going to be related to that. So it might be a good idea to go back and watch that. I have a link to the previous video in the description of this video. Go ahead and pause this and take a look. Today what we're going to be talking about is we're going to be talking about arithmetic operators like plus, minus, multiplication, division, how you can overload those in your own function. And why would you ever want to do that? Well, what if you want to add two objects together and create a third that has the sum of those objects? Now you might think, why would I ever want to add two puppy dogs together? Well, there's a lot of object-oriented programming out there that doesn't model puppy dogs. It models actual arithmetic or numeric classes, objects, and you may want to add those together like in a matrix or a vector. So definitely something that's very useful. We're going to stick with puppy dogs because it's kind of fun, and let's jump right into it. Okay, so I have my Eclipse up and running here, and again, you can use any integrated development environment you want. You don't have to use Eclipse. Again, the reason why I'm using Eclipse is it's just so simple to create classes and things like that. So what I've got here is I've got a project called Operator Overloading. And the previous one was operator overloading for decrement and increment. So go ahead and take a look at that video if you haven't seen it. And right now that main function is empty. But we still have the puppy dog class that we created in the previous video. And you can see that we've got some getters and setters for a single attribute within that class called weight in ounces. You don't need to have a lot of attributes in the class to be able to demonstrate operator overloading, so I just added that one. And then we have the prefix and we have the postfix, plus, plus, and minus, minus operators defined. So what we're going to want to do right now is we're going to want to overload the plus, minus, multiplication, and division. But before we do that, let's actually go into our main and let's go ahead and pound include puppydog.hpp, just so we can have access to it. And what I'm going to do is I'm going to come down here and I'm going to create a puppy dog pointer called my dog and just say it's equal to a new puppy dog. And then what I'm going to do is I'm going to say my dog dot, and I'm going to set weight in ounces. I'm going to make them 96 ounces. Again, you can put any number in there you want. And then I'm going to say cout my puppy dog weighs, my dog dot get weight in ounces. Just something to make sure the class works and do our initial build. Okay, here we go. Let's go ahead and play that, and you can see 96 ounces. So our class is working great. Again, if you don't have this class called puppy dog, you can use any class that has a numeric value in it, or just go back to the previous video and see how I put that together. Okay, so now let's go ahead and add 10 ounces to our puppy dog. So I'm going to say my dog dot, and I'm going to say set weight in ounces. Now I could just type in 106, but because these attributes are private, we have to use functions. So we have to use getters and setters to access them. And one way to do that, in the set weight in ounces, I could say my dog dot get weight in ounces plus 10. So there's nothing wrong with that, but it's a little bit clunky because you've got multiple functions in the same line of code, which is arguably not a problem. But let's go ahead and just do that. And that's one of the reasons why you might want to overload the arithmetic operators in C++ is to let it look a little less clunky. I'll probably get some argument about that, whatever. Okay, So here we go. So our first puppy dog was 96, or our puppy dog's weight was initially 96 ounces. We went ahead and added 10 by grabbing the get weight in ounces, and we added 10 to that return value, and then we set the value in our puppy to that new, which is 106, and then we printed it. You can see it's 106 there. Okay, pretty neat. So wouldn't it be nicer though if you could do something like this? My dog equals my dog plus 10. Wouldn't that be kind of neat if you could do that? Or if you could say my dog plus equals 10. But if you do that, because this is a pointer, what's going to happen is you're going to be adding 10 to the address of the dog. You're going to be messing up your pointer and your program's going to die. If you look at the increment, decrement video I did, I actually showed that as a demonstration. So the compiler will let you do that. If I save and build this, the compiler will let me do it, but it just isn't going to work. Now, one thing I forgot to do down here is I forgot to delete my dog. Whenever you dynamically allocate an object or a data type, you should always delete it at the end. And I'll show you what's going to happen. I'm going to go ahead and run this now. And I'm trying to delete my dog, but I added 10 to the address. So I have a cout program ending have a nice day here. Let's see if we actually get down to that. And you can see it died. It died with an exit value of -1 because when we tried to delete my dog did not have the correct address in it because I added 10. So you can't really do that. But you can overload the plus equals, you can overload the plus, the minus equals. You can overload those functions within the class, which is what we're going to do. So what I would like to do is I would like to say my dog equals my dog plus 10. And that's automatically going to add 10 to the weight in ounces. And now, not yet, we haven't overloaded that function yet. So let's go ahead and put that there, that cout. Okay, it's not going to work correctly because we're updating the address. So in this case, so let's go ahead and overload that function. Now, what we're going to do is we're going to go to the puppydog.hpp file, and we're going to go down here, and we're going to say puppy dog, because you always have to return the object when you overload an operator like this. And I'm going to say operator plus. And then what goes in the argument is the right side of the assignment, of the right side of the arithmetic. So I'm going to say operator plus. Actually, yeah, that's true. So what is it we're wanting to do? We're wanting to take a look at this function. We want to take my dog into the right side of the plus sign is the number 10. That's an integer. So we're going to come over here and we're going to say integer, right value. Okay, and I'm going to do the same thing with minus, so we can implement them both at the same time because they're going to be very, very similar. So let me go over this one other time. So if I say my dog equals my dog plus 10, the 10 is going to be inside of this right value argument. My dog is going to be the current object that is running this operator plus function. Same thing here. If I come down here and if I say my dog equals my dog minus 100, what's going to be inside of the right value? It's the value to the right of the minus sign. That's going to have a value of 100 in it. The object that's actually executing this operator minus function is my dog, the left side, and my dog equals, that's the assignment, that's what we're returning in the function. Okay, a little bit different, but that's how it works. That's how you overload the plus and the minus operator. The increment and decrement were pretty much the same way, but the plus and the minus are this way. Also, the multiplication and division, exactly the same way. We might not actually implement those in this video, but they work exactly the same way. Okay, so let's go ahead and now out of the HPP file, let's go ahead now into the CPP file, and we're going to actually implement those functions. Okay. Let's get to the bottom. All right, so I'm just going to paste those, And I need to put the puppy dog colon colon in front of each one just so I can identify that those operator overloads are part of the puppy dog class. And let's go ahead and get those functions ready. Okay, now just like with the incrementer or decrementer overloads, what we're going to do is we're going to return a dereferenced this. And that's going to return the left side of the assignment statement. So that's where you're going to get that. Okay. So now what do we want to do? What do we want to do with the operator plus? Well, we want to add, in the case of operator plus, we want to add what's the right value is. We want to add that into the current object, the current puppy dog's weight in ounces. So I'm going to say this dot weight in ounces equals this dot weight in ounces plus right value. And of course, you could have used the plus equals if you want there, but I decided to do it the longhand way. And I'm going to go ahead and do this on the minus, but instead of plus, I'm going to say minus. Now, I've had students ask me before, do I actually have to do arithmetic in the plus or the minus operator? No, you can do a cout. You can open a file and write out an infinite amount of data. It doesn't matter what you do in there. You as the programmer are going to decide what it is that I'm going to do when the user says plus some value. Something else that we could do is we could create an operator where you can add two dogs together. Let's do that after we get this working. Okay, so I'm going to go ahead and build this. Looking good. Now let's actually implement it. Oh, we already did. We said my dog equals my dog plus 10. Okay, let's go ahead and run it. Let's see what we get. Okay, well, we have a little bit of a problem here, and the reason is because this is a pointer. We're still adding 10 to the pointer, and we need to dereference that variable, that pointer, so the program dies. We never see program ending have a nice day. So I'm going to go ahead and just put an asterisk of dereferencing on there. Let's go ahead and save and build that. And now let's run it. And it works perfectly. So remember, our dog had 96 ounces when we first initialized it. Then we went ahead and we did the longhand way of doing it, which is perfectly fine. Not as quite as pretty as doing something like this. Now, I will say that this method is very, very self-documenting. You know exactly what that code is doing. It's getting the current weight in ounces, adding 2 to it, and then putting it back in the weight in ounces. Yes, that's very, very self-documenting. I'm a big proponent of self-documenting code, so that works out great. However, this is much shorter. If you only have one numeric value, only one integer variable inside of my dog, why not? Why not do that? Let's go ahead and do the subtraction now. Let's test our subtraction. Instead of plus, we're going to say minus. And you know what I'm going to do? I'm going to go ahead and build and run this, make sure it works, and I'm going to debug it. I'm going to show you just how you can debug this. So it's at 106, then it went up to 116 when we did this line of code. Then we did this line of code and subtracted 10 and it got 106. Now I would like to actually debug this. So what I'm going to do is I'm going to create a breakpoint right here on this minus. And I'm going to go ahead and press the debug button. Say, yes, I want to look at the debug perspective. And now let's go ahead and press the continue. Now we're here on the plus. Instead of pressing the step out over, I'm going to press the step into button. The mouse pointer is kind of hiding that, but it says step into. And this will actually take me into the function operator minus. And there it is, operator minus. So it gets the weight in ounces, which is 116. The right value, as you can see, is 10. By just moving my mouse over the variable, the debugger will show me that in Eclipse. And it'll subtract 10 from 116, you get 106. So let's go ahead and run that, or just step over it. And there's my 106. Pretty awesome. Now you can do this with multiplication or division, and it works exactly the same way. You would go into the HPP file, and you would do something like this. And let's do multiplication. You could do division. It's exactly the same thing. So let's go in here and now go into the CPP file. I'm just going to take this function, paste it twice, change this to multiplication, multiply it by the right value, change this to division, divide it by the right value, save it. I'm going to go into my main here, and now I'm going to say my dog equals my dog times 10. So because we've overloaded the multiplication operator, this should be a pretty fat dog once we get it running. So let's go ahead and run this and see if that's the case. That is a big dog. So it took the 106 and it multiplied it by 10 because we overloaded the multiplication. And I could just go ahead and put that dog on a diet, divide it by 10, run it, and now the dog's back pretty good shape. Now, what if you want to send a, what if I want to divide it by 10.5? What if I wanted to do that? Well, I can go into the HPP file and I can overload the division, except with an integer, we're going to overload it with a double. So let's go ahead and try that out. Now, a little piece of advice here. You're going to be creating an integer. You're going to be updating an integer, so any fraction is going to be knocked off. But what if we had a 100-pound dog and we want to multiply it by, or divide it by 0.5? You can do that. You can actually do that. It'll result in an integer, but it'll give you somewhat of what you're looking for. So let's go ahead and do that. Now, I haven't actually tried this yet in this particular example. Okay, so this weight in ounces, what I'm going to do here is I'm going to say double temp double. And I know there's another way you could do this. You could do it with a temporary typecast. And I'm going to say is equal to this dot weight in ounces. And then I'm going to say temp double equals temp double divided by right value. So this way we can actually have a double, a floating point result, and not just pure integer. And then, which I think might even give us a 0, I don't know. And then I'm going to say this dot weight in ounces equals temp double. And that will then cut off the fraction. Oops, got a P there. Let's save it. All right, let's see if this works now. So what I'm going to do is I'm going to divide it by 10, but then I'm going to divide it by 0.5. Now, by default, the compiler is going to see that 0.5 and say it's a double, so it's going to execute the division, the operator divided by, that takes a double as an argument. Let's go ahead and build that. And what I'm going to do is I'm going to turn off that breakpoint. I'm going to turn on the breakpoint on line 31. I'm going to debug it because I want to make sure it goes into the correct operator overload function. Let's go ahead and run it. Now we're in there. Let's step into and take a look. Now, instead of being in the integer version of the operator overload division, it's now in the double version of the operator overload, and both of them take a puppy dog object as the result. So let's go ahead and just run that. Let's see what it outputs, and you can see right there. So it divided 106 by 0.5, and we got 212. So you can have multiple versions or multiple operator overloads, if you would like, in your code. Okay, so the next thing I would like to do is I would like to be able to add two dogs together. So I would like to create another, let's create another one. I'm going to say puppy dog my dog 2 equals a new puppy dog. So I would like to add those two puppy dogs together into a third puppy dog. So I'd like to do something like this. Now let's go ahead and let's delete all of those before I forget. I don't want to have a memory leak. Okay. So I would like to do this. I would like to say my dog3 equals my dog2 plus my dog. How do we add two puppy dogs together? How could we possibly do that? Well, operator overloading again. Let's go back into our code and let's create a new plus that's going to add two puppy dogs together. So this one, instead of an integer, whoops, is going to get a puppy dog by reference. So we want to send it by reference. We don't want a copy of the puppy dog. We want the actual puppy dog. Okay, so let's go ahead and copy that declaration and let's implement it. Okay, so now instead of an integer inside of the argument or instead of the double, we have an actual puppy dog. So how are we going to add that puppy dog together? Well, we only have one attribute. When you have multiple attributes, this is going to be a little more complicated. You might want to concatenate strings of the attributes or strings. If you have floats, you might want to double those, or you might want to, add them together. But in this case, I'm just going to say this dot weight in ounces equals this dot weight in ounces plus right value dot weight in ounces. And then we say return this. So it will then put that puppy dog in the left side of the assignment. Now, we may not want to have puppy dog 3. We may just want to say puppy dog 2 equals puppy dog, or my dog 2 equals my dog 2 plus my dog. We're adding those two dogs together. So let's do it that way just to make it easier to understand. So it's like we're adding the weight of my dog into my dog 2. Pretty much kind of like how we did the additions here. So let's just go with that, because we're just playing around here to learn the concepts. Okay. So let's make sure our code looks right. So this weight in ounces equals this weight in ounces plus the right value, which is the puppy dog on the right, which in this case is my dog, its weight in ounces. And then we're going to return the object this. Now, one problem we have here is that we have pointers. So what this is going to do is it's going to take the pointer address in my dog 2, add the pointer address in my dog, and put it in my dog 2. It's going to totally screw up my dog 2. So what we really need to do here is that we need to dereference my dog. So I'm going to dereference my dog 2, and I have to do it over here as well. Okay, and we might want to dereference this, so we just dereference them all. Now what we could do is we could make this a puppy dog pointer, and then we won't have to dereference this on the right. And you could do that. Let's go into our HPP file. Let's go ahead and dereference, or let's create a pointer. So let's say we're going to return a puppy dog pointer, and we're going to get a puppy dog pointer as an argument. So you can do that with pointers as well. The code is just a little bit different. Now, why would you want to do both? Well, because you want your class to be as useful as possible. Okay, so we're going to put a pointer there, pointer. This dot needs to change to dash greater than, and we're not going to return asterisk this, we're going to just return this, because this is a pointer. Let's go ahead and build it. Great. Now we haven't used that. Sometimes when you compile it, you have an issue. So let's go ahead and just change this to pointers. Now one problem with doing this is that this is still a pointer, and it's still going to add this pointer address to this. It hasn't actually executed the operator overload. So we have to at least dereference one of them. So we have to dereference this one right there. Let's go ahead and save and build it. Okay, looks good. Let's print it. And this time we're going to print my dog 2. And let's make sure we've got everything. Okay, good. Let's see how this works. Okay, this may have worked. I don't know. Let's go ahead and make sure that we have the value there. Okay. Let's make sure this works. Now we don't know what my dog 1 is, so let's go ahead. My dog weight is, and my dog. So this way we have both numbers, so we can do the arithmetic to see if the code worked. Okay, here we go. So my dog 2 test, the weight is 0. So the weight of my dog 2 is 0. My dog weight is 212. So when we add them together using the reference dogs, my dog 2 now has a weight of 212 because we added 212 to 0. We went ahead and did it this way where we sent pointers to the class, the operator, and now it's 424. 212 times 2 is 424. So pretty neat how that works. Now, one other thing I just wanted to mention, you can do the same thing with plus equals. So let's take a look at our plus here. If I wanted to overload the plus equals, I would simply say plus equals. It works exactly the same way. So I'll put that there. Let's find the plus. Let's make that plus equals. And it should automatically work. You didn't really have to make any changes. Let's go ahead and say my dog 2 plus equals 300. Crazy fat dog. Let's print off my dog 2. And oops, I forgot to dereference this. How did I know I made that mistake? Because I've got an invalid weight of 0. It should have been 724 ounces. Heavy dog. So let's dereference it. Let's run it, and you can see the 724 ounces. So plus equals works that way by simply declaring it just like you did plus. There's the plus equals. And then implementing it identical to the plus. Now, it doesn't have to be identical. It could be something different. But in this case, we just did it that way. So one thing to take away from this is that if you're using pointers, you have to dereference the information. If you're not using pointers, you don't have to do that. So if I say puppy dog static dog 1, and then if I say static dog 1 dot set weight in ounces, make it 10, then I can say static dog 1 plus equals 100, and then I can say count static dog 1 dot and you don't have to do the delete either because it's a static puppy. Okay, let's build it, make sure everything looks good. Okay, so what we should see is that we should see 110 because we set the weight of the dog to 10 ounces, then we did a plus equals 100. You could have said static dog 1 equals static dog 1 plus 1, but we didn't do that. We just did the plus equals, and there you go, 110. So pretty cool that it works both ways, both for static as well as dynamically allocated objects. All right, so that is simple arithmetic, operator overloading. I've used it many, many times in my career. I've taught it for years. It's really, really powerful. It's really, really neat to do it. Go ahead and practice it. Try different classes. You know, put multiple increments. Let's say if your class has 5 different numeric variables and you decide to override the asterisk, you know, the multiplication symbol, and then every number you multiply it by that right value. That's kind of neat. It's really, really powerful operator overloading in C++. Hope to see you in our next video.